Good day everyone, I am Bismarck A. Makatigib, a third-year BS Ed Math student at Norsus Shatin campus. Today, I am going to discuss about Discrimination Index, but before that, let me ask you a question. What do you think is the purpose of Discrimination Index? If you have any ideas, you may comment it in the comment section. So, what is Discrimination Index? Item discrimination refers to the ability of an item to differentiate among students on the basis of how well they know the material being tested. The discrimination index is a basic measure of the validity of an item. It is a measure of an item's ability to discriminate between those who scored high on the total test and those who scored low. Comprehensively, discrimination index is the difference between the proportion of the top scorers who got an item correct and the proportion of the lowest scorers who got the item correct. A way to derive such a measure is to measure how difficult an item is with respect to those in the upper 25% of the class and how difficult it is with respect to those in the lower 25% of the class. Though there are several steps in its calculation, once computed, this index can be interpreted as an indication of the extent to which overall knowledge of the content area or mastery of the skills is related to the response on an item. Perhaps the most crucial validity standard for a test item is that whether a student got an item correct or not is due to their level of knowledge or ability and not due to something else such as chance or test bias. Here are the steps in calculating the discrimination index. First step is to compute each student's score, that is, count the number of items each student got correct. Our second step is divide the class into groups on the basis of total score, 25% highest scores, and 25% lowest scores. The middle group, middle 50%, is not needed in computing discrimination index. Our third step, for each item, count the number of students in the high scoring group that got the item right. Our fourth step, divide this number by the total number in the high scoring group. Our fifth step, repeat steps 3 and 4 for each item, this time using only the low scoring group. For our last step, for each item, subtract the proportion of low scoring students who got the item right from the proportion of high scoring students who got it right. The remainder is the discrimination index. Next is we have our discrimination index formula. Discrimination index is equal to du minus dl, and discrimination index is equal to ru minus rl over 1/2 times t, where ru is the number of students in the upper group who answered correctly, rl is the number of students in the lower group who answered correctly, and t is the total number of students who answered the item. Let us have an example. Consider a multiple choice type of test of which the following data were obtained. This is our given data. It is provided here that the correct answer is B. We will first follow the formula di is equal to du minus dl. But before we proceed, let us first find the value of these two. For our du is equal to 15 over 20, which results to 0.75. And for our dl is equal to 5 over 20, which results to 0.25. Now that we have the value of du and dl, let us substitute and subtract. 0.75 minus 0.25 is equal to 0.50 or 50%. Therefore, the item has a good discriminating power. Note, distractor A is not an effective distractor since this was never selected by students. It is an implausible distractor. Distractors C and D appear to have good appeal, hence plausible distractors. Now, let's proceed to our second example. What's the discrimination index of an item with the following number of students who got the correct answers from different groups? There are 80 students who took the test. Upper group 16, middle group 12, lower group 10. We have our formula di is equal to Ru minus Rl over 1 half times t. So the value of our Ru, which is the upper group, is 16, and for our RL, which is the lower group, is 10. Then our T is equal to 40 since there are 80 students who took the test, and the middle 50%, which refers to the 40 students, is not included in computing the discrimination index. Next is, we will subtract 16 minus 10, which results to 6, and 1 half times 40 is equal to 20. So 6 divided by 20 is equal to 0.3. As for the discrimination index, we have the following arbitrary rule. Range of discrimination index negative 1.0 to negative 0.50, our interpretation, can discriminate but item is questionable. Action is discard. Negative 0.51 to 0.45, our interpretation is non-discriminating, our action is revise. 0.46 to 1.0, our interpretation is discriminating item, and our action is retain. That ends my discussion. If you have any questions, don't forget to put it in the comment section below, and you may also share your insights and thoughts on discrimination index. Thank you for listening and have a good day ahead.